Hi guys, I was once asked on my channel from a viewer here in Thailand what the most common sort of repairs are here, and I'm talking about electrical work, and what everybody should maybe have at home as spare parts to get that fixed as quickly as possible. Of course, here in Thailand, we have a hot and humid climate, so electrical appliances and devices, equipment is having a hard time here. And as everywhere else in the world, most of the time we would have to change light bulbs, of course. I have LEDs here on my property already for 10 years. And they are dying not after 25,000 hours, they are dying in average after 3,000 hours. But it's not what we are talking about today, because everybody knows how to change a light bulb. So we are going to the number 2 issue, which we will find here, and that are run capacitors of electrical appliances, so where you have a motor inside. So which sort of appliances do have motors which require run capacitors? Run capacitor, as you have it here on the table, several different kinds, are always installed in appliances which do have brushless AC one-phase motors. Right? So when you have a AC motor, you always need a rotating magnetic field. And when you have a brushless motor, the magnetic field inside the rotor is created by induction from the outside magnetic field. But when you only have one phase, that would create, by the location of the internal winding of the motor, only a magnetic field which is changing from one pole to the other regularly, right, by the frequency of the AC. But it would be always on the same place, so the rotor could never start turning inside that motor. And that's why we need a secondary winding which is displaced inside that motor stator. And when you only have one phase available, you need to create a second phase which is shifted, right, phase shifted. And this is done by capacitors. A capacitor will shift a phase by 90 degrees, and so we can, by just using one AC phase, create a rotating magnetic field. Why is this now a problem? So, as I said, if you have a hot, humid climate, this sort of capacitors will degrade by time, and they can also one time also then shorten. The capacitor types are always high voltage. So here we have like 450 volt AC, 500 volt AC on this one. And they are non-polarized, so this is not like an electrolytic capacitor where you have to look which side is plus, which side is minus. This is made for AC, so non-polarized high voltage capacitors, and they will fail by time. So where are they installed? Here on our place. This here, for example, is a 30 microfarad capacitor. This one is installed in a compressor unit of a split air conditioning set. And this sort, because we have here about 15 air conditioners installed on our property, they will fail sometime in around 3 to 5 years probably. And so if you divide 15 by 5, you have to change about 3 capacitors every year here. And then I have my dishwashers, for example. There we have the water pump, and the dishwasher is pumping the water through the machine for cleaning the dishes. There is also a motor inside. I have changed those capacitors already 2 times on each of the machines. And the third example which I will show you today, which we are working on, those are my ceiling fans, and this is this sort of capacitors. We will talk in a moment about this. And I have also one fan where we have to change it, and we will look into this. Yeah, I show you the ceiling fans, and then I will show you which secondary feature actually the capacitor does have in the ceiling fan. And yeah, then we will exchange that one, and then I have another fan which does not work at all, and we will also have to take a look on that one, why that one is not running at all. Okay, here in my restaurant area we have 3 ceiling fans. So the number 1, you can't probably see it very well on the video. This one is now turning around half the speed of the second one. The second one is turning at a speed which I actually like. They should all run. So they are all set on single speed and are switched centrally from the reception area on a switch. But this one is now just half as fast as this one and needs some attention. So in this one we have to change the capacitor. And then I have the third one there, which is not operating at all, and I don't know why. I have a few years ago changed the run capacitor on that one and nothing changed. So I think we have some problem with some connection or on the switch or whatever, and we will then take a look on that also. But let me explain first how speed control works on this sort of fans. These are the sort of capacitors which are built into the fans, and normally standard is this combined run capacitor. It's actually 3 in one case. So why is this? If you know this sort of ceiling fans, you know there is a small chain on it which is connected to a switch, and you can actually change the speed of the fan by pulling on the chain and change the switch positions. But what I have done, I removed this sort of, this is a 3-speed capacitor here. I removed this and I just replaced it by one single capacitor. So I have changed this fan from multi-speed to single speed. I have just selected the most preferable speed setting, and yeah, this is just switched on and off, so nobody should play around on the fan anyway. And you can see here each of these capacitors has a different value. This is a 1.8 microfarad, 2 microfarad, this is a 3 microfarad. So the meaning of that value actually is not just that that fan is capable of rotating, it also changes the speed settings. That means that higher capacitance values will result in higher speeds. The 1.8 microfarad capacitor will turn the fan in a certain speed, and if I would use the 3 microfarad on the same fan, this would then turn much faster. So why do they need to be replaced? You know, by time that capacitor will degrade and the capacitance value will start to be smaller and smaller, and this is therefore resulting in the fan starting to reduce its speed. And that's how you can see that there is something to do, that you have to replace the capacitor if the fan suddenly starts to reduce the speed. And yeah, in that case, which we have today, it's maybe now half of the speed than it was at the beginning. So now, of course, everyone can change a light bulb. Why do I think that this is a DIY job? Why don't you have to bring this fan to a service center or bring somebody who can do this? Well, these capacitors, of course, if it's a multi-speed one, there's a lot of wires to connect. But if you choose, like me, to only set it to one speed, at the end you only have something with 2 wires, and you just find the common wire there on the input, and you go to one of the switch positions, and then you just crimp on 2 wires, and that's already it. It's very easy to open such a fan. It is designed to be serviceable, and we will see now how this goes in detail. These are the tools and items we need for this repair. And yeah, we have our capacitor. We have 2 such crimping end caps. So because we only need to twist wires together, put this on, and then use the crimping tool and press it together, and that's already it. We need a screwdriver to open the fan, and maybe we have to cut some wire somewhere, but that we will see. Okay, and that's already it. Very simple. Let's look at the fan, how this is done. You can see each of these fans. Below the motor you have this compartment here, and this compartment has a cap, and there are 3 screws which need to be opened. Just before you start your work, always turn off the electricity. But as you can see, very simple. Just open 3 screws. And yeah, this is already all we will see today. Inside of this compartment, the electricity from your supply will come here out of there in the middle, and then you have here all the connectors. This here is the old capacitor, 1.8 microfarads. We will take this off here, uncrimp this, and just put the new capacitor on this, and that will be it already. Close shot of this compartment. Everything is coming out from there, from the middle, and then is just used inside this compartment, connected to the wiring, to the windings and switches, etc. Uncrimp this one. You can actually, if possible, use the same cap again. Just uncrimp it. By pushing the crimp connector inside there and the other way. Okay. Twist the new ones together. Take the cap. Crimp it back together. So, okay. Right, and that's it. We can close it up again. Just put the capacitor inside there. So as you can see, this only takes a few minutes, and if you have to do this in a service center or by a service technician, this would cost you quite a lot of money, and like this it only costs the amount, the price of the capacitor, which is less than $1. And yes, now it is turning the same speed like the other one again. Okay, so this here is now the 3rd fan, which is not working at all. The capacitor is removed, and what I want to try here is simplify the system completely. Maybe, you know, maybe the switch or something internal is broken and I want to connect then just straight the input to the wiring of the motor and the secondary wiring just via the capacitor. So remove the switch there. There's another switch, this one is changing the direction of the fan, so maybe we can keep this and yeah, and just remove this one. Probably there will be some problem there. Okay, removing this switch did actually not do anything, so I'm now also going to bridge this switch here, which is just turning L and N so that the direction of the fan is changing. I will remove all of this and then just connect L and N. Okay, and unfortunately, as I have now removed the other switch also, I have now connected my multimeter on the primary winding of the motor. So orange and yellow, those are the primary winding, and if you check continuity there, yeah, it's open. That means this fan has a primary winding issue. So this is for the time a no fix. Let's see if I can take it off, because it's now only decoration, and if we can open up this motor. If not, then yeah, it will stay decoration. But I have another one, a spare one, so probably just put the other one up here for the time then. But just to show you, you know, the secondary winding here, blue wire and gray wire, 280 ohms. So yeah, just the primary winding probably burned through, or maybe something got loose inside the motor. I've now removed what I could from this fan, and at the end, you know, now this part here should be pulled off the casing here, but this is all already rusted and it's not moving anywhere. So yeah, I don't have the time to try and bring this off somehow, and then just to find out that the wiring is burned out or anything. So I would say this fan is deemed a no fix. I will get my spare fan, mount that one, and yeah, then we have 3 again here. Yeah, it's quite cheap, these fans. It's not always worth to repair it. I have installed my spare fan. It's already extremely rusted. It looks very antique, and it was still original here inside. Yeah, so I have removed the 3-speed capacitor and replaced it by the single speed, and also removed the switch, and it's working already. I have to install the fan blades, and that's it. Fans are working top speed. We have a little bit of wind again here. Right, so you see, changing a running capacitor is nothing too complicated, and it's just, you know, the one-phase induction motors, or maybe this one is a permanent magnet motor. It's quite easy to understand. Only have 2 windings and a capacitor, and that's already it. Let's call it a successful repair. Okay, so thank you for watching. I hope you got a little bit of understanding about this kind of motors now, and yeah, please comment, like, subscribe to the channel, and I see you next time.